Mr. T here with a tutorial on solving quadratic equations, and today we're going to be solving them using what's called the quadratic formula. In earlier lessons we've talked about solving by factoring, solving using square roots, and solving by completing the square. So today we're going to use this thing called the quadratic formula. The quadratic formula is an effective way of solving quadratics in that it works for every quadratic equation that is solvable. However, it can be error-prone in the calculations and simplification. The quadratic formula is given here at the bottom, and these letters A, B, and C refer to the coefficients of the x squared, the coefficient of the x, and the constant when the quadratic is in standard form, meaning equal to 0. We get two solutions potentially when we use the quadratic formula because we've got plus this radical and minus the radical. And this division in the bottom by 2a, a common mistake is to only divide it into this part, but it divides the entire numerator. The biggest issue with the quadratic formula for many of you is making errors using either improperly using order of operations and also making mistakes with negative numbers, especially here when we square and in this multiplication. So we'll talk about those as we get to specific examples. So here's our first example. Now, first mistake would be this is not A being 1, B 5, and C 14 because this is not in standard form. So we need to write the equation in standard form by subtracting the 5x and the negative 14. So now we can figure out our A is 1, our B is negative 5, and our C is negative 14. Next step, or the first step in using the quadratic formula, is to substitute into our formula. All the symbols, the minus, the plus minus, the square root, continue, they're part of the formula. So the fact that the b is negative is not this negative, it's here. I'm putting the b in a parentheses here because if you're using the calculator to calculate under the radical, you need to make sure to put negative numbers in parentheses, otherwise you're going to get the wrong number in the calculator. And that's all over 2a. Now the first several examples we're going to work, we're not going to plug this in and get a decimal number. We want to get an exact value. So our first thing that we want to compute is this number underneath the radical symbol. And I'm also going to take care of this minus a minus here. Now, under the radical, we've got negative 5 squared. Let me do this over here, which is 25, positive 25. And here I have negative 4 times 1 times negative 14. So negative 4 times 14 is, what do we get there, 56. So that comes out to be 81. So we have here the square root of 81. Oops, I had forgot to substitute in for this a. This a was 1, so that was 2 times 1. So this is all over 2. Now this time we got lucky, so the radical is a perfect square, so we get plus or minus 9 over 2. Now we can't divide here, especially if that had been an even number, we might be tempted to divide. We have to do the computation on the top first. And we want to split this up into two calculations, 5 plus 9 divided by 2, and 5 minus 9 divided by 2. So here we get 14 divided by 2, which is 7, and here we get negative 4 divided by 2, which is negative 2. So those are two solutions to this quadratic equation. If we wanted to check, we could plug in 7 for those two x's and simplify, or the negative 2 and show that it verifies. Let's look at another example. So here we have in standard form, so A is 6, B is negative 1, and C is negative 2. So now we have negative 1, plus or minus the square root of negative 1 squared minus 4 times 6 times negative 2 all over 2 times 6, which is 12. So when I simplify here, I've got positive 1. Again, we're going to calculate under here, so 1 squared is 1. And here we've got negative 24 times negative 2 is positive 48, which is 49. So again, we end up with a perfect square under the radical. So now we have 1 plus or minus 7 over 12, and we're going to split that into two numbers. Gives us 8/12, and both those numbers are divisible by 4, so we get 2/3. And here we've got 1 minus 7 over 12, which gives us negative 6 over 12, which reduces to negative 1/2. So again, in this example, we had a perfect square under the radical. In our next example, this number we get won't be a perfect square, and we'll show how to handle that. So now our A is 10. Whoops, it's not 10. Our A here is 1. B is 10. Just looked ahead. And C is 22. So we have here negative times positive 10, so we have negative 10 plus or minus the square root. Now we have b squared, so we have 10 squared. Now I didn't put it in parentheses this time because that's a positive 10. 22 here, all over 2. So now we have negative 10 plus or minus the square root. Now here, under here, we have 100. Now we have here negative 88. So that's positive 12. So we have radical 12 over 2. Now a common mistake might be for some to cancel out here. We can't do that. We've got to divide into both. Secondly, some people might divide here, take 12 divided by 2 and put square root of 6 here. We can't divide a number that's not a radical inside of a radical. Radical 12, though, can be split up into radical 4 times radical 3, which is 2 radical 3. So now we're going to rewrite this as negative 10 plus or minus 2 radical 3. When we have a fraction bar here, I call it, where we're dividing an expression, we can simplify it by what's called dividing out. So we can divide here and here. So we get negative 10 over 2 plus or minus 2 radical 3 over 2, just splitting that up. So here we get negative 5 plus or minus, and here the 2's cancel, and we get square root of 3. This is two solutions, negative 5 plus radical 3 and negative 5 minus radical 3 for our solutions, but we're going to leave it in exact form, so we're not going to calculate those two numbers. In the next problem, we're going to look at calculator usage if we're looking to get a decimal number. So here we've got something with some bigger numbers. So here we have A is negative 16, B is 45, and C is 1. And this time we want to find a decimal answer rounded to the nearest 100th. Now there's actually going to be two answers likely, so we have to find both. So let's still substitute in. So we've got negative b, which is negative 45, plus or minus radical. Now we've got here 45 squared minus 2 times negative 16 times 1. And that's all over 2a. Not 2a. 2a is here. Let's fix that. A is negative 16. You could put down there negative 32, simplify some things using your brain. So let's bring out a calculator here. Now, I like to, if you can deal with the parentheses to put this entire formula into the calculator and let it do all the right order of operations. We need to put a parentheses around the entire top, and we have to put a parentheses around this calculation to cause the calculator to do the right order of operations. Likewise, if this number is negative, which it's not this time, but we need that in parentheses there. So let's start to enter this. So we have here, we need our opening parentheses here. Now we have negative 45. Now we can't do plus or minus, so we're going to do a plus the first, and then we'll edit it to do the minus. So now we've got the square root. And now we've got 45 squared. Now I'm going to pretend that was a negative number and just show we would want to put that into parentheses and square it. Now we've got minus 2 times negative 16 times 1. Now I use the times symbol here instead of those parentheses. You could use the parentheses if you want. Now I'm closing the parentheses on my square root. And now I have to also close my parentheses here. Divide. Now on the bottom we are doing 2 times negative 16. Close the parentheses and hit enter. And so we get one of our solutions, the solution with the plus here, to be negative 0.01 if we round it to the nearest hundredth. Now we could type this entire thing in again, but the only thing we want to change is that plus to a minus. So using a graphing calculator, we can bring up the previous calculation by using second entry. So second and the enter key. And this brings up that previous calculation in edit mode. We can use the arrow to go back to that plus. And we're going to change that to a minus and just press enter. And now it calculated the other answer, and we get x equals 2.82. With a little practice in using these parentheses here, this is really the best way to do the calculations. If you do it piecemeal, you would want to do this calculation first, then add this, hit enter, and then divide. So you'd have to do that, but then it makes it harder to repeat the process when you want to edit. The other thing that's best not to do is to round in each step, because the errors will accumulate. So if we do this step first and round it, now we're going to start introducing additional error. One last thing on the quadratic formula. Let me get rid of the calculator here. Sometimes all we care about is how many solutions a problem has. We might not necessarily need to know the specific solutions. We just want to know, are there solutions? And so we use something called the discriminant. Well, what is it and what's it good for? The discriminant is a portion of the quadratic formula, and it's the portion under the radical symbol. So it's this calculation here, b squared minus 4ac. So if we calculate that subset of the quadratic formula, we can determine how many solutions there are. If that number under the square root, remember this is under a square root, if that's negative, there are no real solutions to that. You can't take the square root of a negative number and get a real number. So that would mean that that's undefined, so we have no solutions. If in our formula the square root, we get the square root of 0, we're going to have here, if this is 0, we've got the square root of 0, which is 0, so we've got negative b plus 0, which is negative b, and negative b minus 0, which is negative b. So we get the same answer, so we end up with just one real solution. And then in the other examples we've been doing, this comes out to be some number bigger than 0, and we've seen we have 2 real solutions. So our last problems here, if we had this and it just asked how many solutions, we're going to calculate for each one, we're going to calculate b squared minus 4ac. So here b squared is negative 6 squared is 36. Minus 4 times 1 times 9, which is 36 minus 36, which is 0. So that tells us this problem has one solution. If we look here, we get b squared is 36. Now we have minus 4 times 1 times 10, or 36 minus 40, which is negative. That's less than 0, so we have no solutions. And our last one comes out to be 36 minus 32, which is 34. It's 4. And that is bigger than 0, so this problem would have 2 solutions. So again, that just tells us how many solutions. This kind of problem shows up here in New Jersey frequently on our high school proficiency test, and I've seen it on SAT tests. So again, this is using the portion of the formula called the discriminant. And again, you don't have to remember separate formula, just remember that it's the part under the square root. So good luck using the quadratic formula, and happy computing.